guys, welcome back to my channel Informatics. In this episode, we will be learning about solar eclipses and the first of the planets, Mercury. Alright, so first let's move to solar eclipses. So something as constant and unerring as the sun's light is suddenly interrupted by something. We cannot fail to notice. For a few minutes, it seems as if the world stands still. History books are littered with the tales of the sun disappearing. Today we call these events solar eclipses. So every so often, during its steady crawl around the earth, the moon occupies the exact same amount of the daytime sky as the sun. So since the moon is closer, its presence obscures our view of the sun, causing an eclipse. What are total solar eclipses? Now, as the name prefers, total solar eclipses are the sun is totally or completely hidden by the moon. Now, total solar eclipses are actually one of the nature's ultimate spectacles because the sky darkens and the temperature drops and the birds stop singing. Alright? So just imagine if the moon orbits on the line that is exactly between the sun and the earth, we would have seen the eclipse every month. But unfortunately, the moon's orbit is tilted by 5 degrees. We see the eclipses every 18 months or so. Now let's take a look at annular solar eclipses. Now, annular solar eclipses are the solar eclipses which sometimes this moon fails to cover the sun completely or totally, so allowing us to see the edge of that outline like a ring, a small ring. All right, so this annular solar eclipse comes from the Latin word annulus, which means little ring. And a hybrid solar eclipse, and a very unusual event. It happens sometimes as a total solar eclipses or annual solar eclipses in many places. And also one thing, if an eclipse is occurred, the eclipse cannot be seen from the whole earth cannot see the eclipse, because where the moon's shadow fall, only those people who are living there, they can only see this eclipse. So that's about eclipses. Now we'll move to the first of the planets, Mercury. Alright, so Mercury is one of the rocky or terrestrial planets. These terrestrial planets are the planets that are made from rock. They're smaller, they're closer to the sun. There are 4 planets that are Mercury, Venus, Earth, and Mars. Alright, so we're learning about Mercury, so let's go. Now, Mercury is a small, tiny, cratered world that is so close to the sun that the sun's emissions scorch around this, blast and scorch around this Mercury. Alright, so the temperature during the daytime on Mercury's surface is 430 degrees Celsius, hot enough to melt lead. And also when it is nighttime, due to the thin atmosphere, all the heat on the surface escapes to space and the temperature drops to minus 180 degrees Celsius. So no other planet experiences such extreme conditions. Alright, so now let's take a look at the rotation and revolution of the planet. So rotation of the Mercury is actually very slow. Alright, so it almost takes about 59 Earth days to complete one rotation. For Earth, it's 24 hours. For Mercury, it's 59 Earth days. But simultaneously, the Mercury's revolution, the orbiting around the sun, it is the fastest among all the planets because it completes its one revolution, its year, in just about 87.97 days, or we'll round it off to 88 days. Alright, so that's about rotation and revolution. So we can say that the day of Mercury is much longer than the year. Alright, so this Mercury has a maximum orbital speed of 50 kilometers or 30 miles per second. So 1 second, it goes in 50 kilometers. Alright, so that's about Mercury. Now we'll take a look at the Mercury's structure. So guys, this is the Mercury structure. We'll start with the crust. So, Mercury's crust is likely to be made of magnesium rich basalt and other silicate rocks. It is 100 to 300 kilometers thick, and the surface is stable with no moving plates, meaning that features such as impacts, craters, remain undisturbed on the planet for billions and billions of years. Next, we'll move to the mantle. So, the semi molten rock of the mantle layer is around 600 kilometers thick. Like Earth's mantle, Mercury's consists of silicate rocks and is far less dense than the planet's core. It is relatively thin layer, accounting for approximately 20% of the planet's radius. Then we have the core. So the iron core is 3,600 kilometers wide, and researchers discovered its liquid state by bouncing radio waves off the planet to measure how much it wobbles as it rotates. So a solid core would have a rigid rotation, but Mercury's wobbly spin indicates liquid sloshing around inside. So this is how researchers discovered it. So by this we complete this was just a little information about Mercury and solar eclipses. So I'll see you guys in the next episode. Thanks for watching.